everybody, and welcome back to another math video. Today we will be learning on how to solve rational equations. Now, a basic overview of what you'll see in this video as of context-wise. We'll go over definitions as usual. So that's just what rational equations are, what are polynomials. We'll learn on how to solve these equations, and this will be like a step-by-step procedure. We will work through some practice questions together, and these questions will just progress a little harder each time. We will do one example of a word problem question, and this is just a good idea to apply all of our knowledge into real life scenarios. And then we will be doing some checking, so just making sure restrictions and extraneous solutions are non-existent. And these terms we'll go over briefly as well. Okay, so rational equation. So before we begin solving, we need to know what the term rational equation is, okay? In the easiest of words, a rational equation is a fraction of polynomials connected by an equal sign. So what does that exactly mean? Well, we know what polynomials are. That's just many, and many variables. It's a expression of saying many variables. So x could be p of x, r, x, y, z, and these could be added, divided, subtracted. These variables could do any order of operation they wish to. Now, when it says it's a fraction of polynomials, then we know that it's just p of x over q of x. That is what we are looking for. And then it is connected by an equal sign. Well, that's just pretty straightforward. Any equation will have an equal sign because we are trying to solve the supposed equation, right? But if it's without without a equal sign, then there's no equation, then it's just an expression. This over here is called a rational expression. P of x over q of x. Okay. Well, that makes sense so far, hopefully. Let's go over to extraneous solutions. So if we think about restrictions from past units in math, that's basically the same thing. It's where a solution it's a solution in which the equation equals undefined. That is what we are avoiding. We do not want a solution that equals undefined. So undefined meaning when your denominator is equal to 0. This over here, this equals undefined. X over 0, any variable over 0 will equal undefined. Okay, so restrictions and extraneous solutions are basically the same thing if you want to think about it like that. Moving on. Okay, how to solve. So we have 5 easy steps on when we are solving these equations. Our first step will be to always set our equations equal to 0. Now, as we progress on to the practice questions, we will go over another way, which is essentially the same thing. We just minus the step of setting our equations equal to 0, but it still has the same context that we are looking for. Then our step number 2 is to state our restrictions. Why is this important? Well, we just realized that our extraneous solutions are our restrictions, right? So we need to state these in order to see and check that whatever solution we get in our answer, if we get x equals 5, we go back to our restrictions and see that this and this are not the same. X cannot equal 5, therefore this is not my answer. Okay, our third step is to divide by a common denominator. Sorry, just messed it up. Okay, so the main point of solving rational equations is to get rid of your denominator. We do not want a denominator. We want just our numerators to equal 0. So when it says divide by a common denominator, that only applies when you have 2 fractions. So if you had 1/5 minus 2/3, what would you do here? You would see what these two share in common. In most scenarios, you could just times the two expressions together and then cross multiply from there on out, okay? So we will be dividing by common denominators, and then step 4 is to eliminate our denominators completely. So we just get one single line, so x plus 5 plus y is equal to 0. We just got rid of our denominator. And most of the time, all of the time, we're just eliminating it by multiplying it in the numerator side. And our last step is to use SAMDA to solve for x. So in easy words, you're just solving from there on out. You have a algebraic expression, x plus 4 plus 9 or something equals 0. What do you do from here? X plus, you're just making x by itself. We want x to equal something. So we just use order of operations backwards, and then we get x equal to something. Okay. Well, now we have a good basic knowledge on where to start. Let's do our first question together. So this will be question number 1. Alright, so question number 1 says to solve for x when x equals 2x plus 6, x plus 5, and this is equal to 0. Well, if we remember from our steps, our first step would be to just set it equal to 0. Now, this is already done for us. We only have one fraction, and it's already set to 0. So we can just continue on from there on out. We might as well check mark this. Okay, state our restrictions. So when we talk about restrictions, again, we are just looking for that denominator section. A denominator cannot equal 0. So in this case, what plus 5 will give you 0? That means we're just canceling out the 5s. So negative 5 plus 5 does give me 0. My restriction will then be negative 5. So in the same sentence, I could just write down x cannot equal negative 5. Okay, so let's continue. Our third step says to divide by common denominator. Well, in our first question, we see that we only have one fraction to work with. This is what we are given, and this is what we are going to work with. So we already have a common denominator if you want to think about it like that. But there's no other fraction to be used. So our fourth step is just to eliminate the denominators. So again, to do that, we just need to multiply this in our numerator to get rid of it. So actually, erase that. So we'll do the same in the next line, we'll write down the same thing, 2x plus 6, x plus 5. But we want to get rid of it, so we can times it, because the opposite of division is multiplication. You want to eliminate it. You times it in the numerator. And then these just get canceled out. So again, what you cancel these two terms out, you just get 2x plus 6 is equal to 0. And then we go back to our steps, and last step is just to solve for x. So over here, we can do this in two ways again. It honestly depends on however way you're more comfortable with. You can move the 6 to the other side. So you want to make x by itself. So you're going to subtract your coefficient first. So you're going to minus 6 from this side. So you'll have to minus 6 from this side too. So you should get 2x minus 6. Divide that by 2 because the opposite of multiplication is division. You're trying to get x by itself. These two get crossed out, and then you're left with x equals negative 3. The second way, these two are the exact same ways, just laid out a little differently for you to see how different ways can be shown. So you get 2x plus 6 again is equal to 0. What you want to see a common factor of 2x plus 6? Well, that's 2. So you can write that down. Then you write x plus 3, right? So because 2 divided by 2x is just, you're left with x. 6 divided by 2 is just 3. So you're left with x plus 3 is equal to 0. Then when you're solving for your x, or you can think of it as zeros as well, This 2 doesn't mean anything. There's no x, we don't need to worry about it. This though, x plus 3 equals 0, well that just means x has to be negative 3. Because it equals to 0, so we move the 3 on this side, and essentially it's just the opposite of what we did. Sorry, the opposite operation of what is inside the brackets. So either way, it really is the same thing. It's just however you find easier for your brain to understand. Let's do question number 2 now. So now the question is going to get not exactly too harder, but it'll just have a little bit more steps for us to understand. So question number 2 says to solve for x when x is equal to 3x squared minus 2 over 5, and that is equal to 15 over 3. Now there's many ways where you can go on from this. This is not exactly a hard equation, it's just seeing ways to cut steps when the more we understand, okay? First thing we can do, we see this equation here, this fraction here, this is just equal to 5. 15 divided by 3 is 5. So in our next line, we could just simplify this and write down that this equation is equal to 5. So let's do that. 3x squared minus 2 over 5. Well, it's equal to 5. Great. Now, for this equation, question, we'll stick to our rules right now, but I'll show you another way where we do not have to set our equation equal to 0, but essentially it's the same steps. We're just working in a different way. Okay, so we'll set our equation equal to 0 then. How do we do that? Well, if we looked at our question number 1, it's the same thing. We're just trying to get 0 on this side, so we'll have to minus 5. That also means we need to minus 5 on this side. So 3x squared minus 2 over 5 minus 5 is equal to 0. Again, referring back to question number 1, we also know that numbers or whole numbers are a fraction of 1. So now we have essentially 2 fractions that we can work with. So now we looked at our common denominators, our denominators for both of these equations are not x's. So our restrictions, which is our step number 2, is irrelevant. Not irrelevant, it just does not exist. We have no restrictions, meaning x can equal whatever. Negative, positive, infinity. Not infinity, but it can basically equal any real number. So we don't have to state our restrictions for this question. Let's move on to the third step. It's to divide by a common denominator. So again, this is just simple fraction work. If this is 5, this is 1, we can just times the other fraction by 5 to get our denominator 5. And then instead of writing these equations, these fractions of 2, we could just write one big fraction. So 3x squared minus 2, then minus 5 times 5 will give us minus 25. This is all over 5. Okay. I don't know why I used blue here, but it's okay. Okay, great. So now we could just see that we have a x squared. We also have 2 coefficients or whole numbers. So we could just do 3x squared minus 2 minus 25 is just minus 27. Now we have a fraction that is simplified to its max, and now it's equal to 0. Our next step is to eliminate the denominator, so we could just do that over here. Times it by 5, gone. Just now we have our numerator. 3x squared minus 27 is equal to 0. So again, just referring back to the first question, we can do this any way you want. If you want to common factor this out first, or if you want to move over and make x by itself, it's the same thing. I find this pretty easy. So we'll work our way backwards through orders of operations. So again, I just added 27 here, meaning I have to add 27 here. I divided 3x by 3 because we're trying to do the opposite operation. These get cancelled out. X squared is equal to 9. And again, when we have an exponent, to undo that exponent, we just square root it. Lucky for us, 9 is a square root, or sorry, 9 can be square rooted. That's our 3. Now remember that whenever we square root a number, there's a plus and minus associated with it. So it could be plus 3, but it also can be negative 3. And that, if we do it the common factoring way, oops, that is present over here too. So again, we have 3x squared minus 27 is equal to 0. We just common factor this, and then we just see a difference of squares over here. So whenever we do this, we get 3x plus 3x minus 3. Okay, and that again is our answer. X equals 3 and x plus 3 are our answers for this question. Great. Now, before we move on to the second question, I do want to show also a way where we do not need to have our first step being setting the equations equal to 0. And here is why. So the more practice we get with rational equations, the more like it makes sense to us. The more steps we see that we can easily cut out. And that's the trick of doing math, is finding ways to eliminate steps and make it easier for yourself. Well, we understand that when you set equations equal to 0 and when your common like we're dividing by a common denominator, it's the same thing as cross multiplying. And that's something that is like learned in previous grades of math. So this, we could just, instead of setting this equal to 0, we can still set this equal to whatever our expression is on the other side. In this case, it's 5. And instead of making this come over here, we could just do cross multiplication. So this is 5 over 1. So that means just times 1 on this side, times 5 on this side. Sorry, this looks a little complicated. But you're just cross multiplying over here. So 3x squared times 2 multiplied by 1 is just the same thing. And then we don't even need our denominator. If we know that we're going to eliminate our denominator nonetheless, we don't need to show it. Again, if the teacher is asking you to show all your work, then you will have to. But if you're just doing this, you don't need to each time show the elimination. We could just move on to our second line. So 3x squared minus 2, that's what it is. 5 times 5, well, that is 25. So now what do? We just do 3x squared equals 25 minus 2. Again, plus 2. See, I made a common mistake here. Make sure you do not do that. You're adding 2, you're trying to get rid of it, so you have to add 2 on this side. You get, then you should get 3x squared is equal to 27 divided by 3. X is equal to 9. Just the same step. It's the same procedure. We're just eliminating lines that we don't necessarily need to do. And again, if this is more confusing to you, then you should go slowly. But if you get this right off the bat, then it's easier to comprehend what you are doing in a more efficient manner. So you should get x squared is equal to 9. And then again, you just square root plus minus 3. Okay. So let's go to our third question. For our third question, it says to solve for x when x is equal to 2x minus 5 over x plus 5. And this is equal to 5x plus plus 4. Okay, so as we learned in the previous question, there's two ways to approach this equation. And it's the same thing. It's just the way that you choose may be longer or maybe shorter. So there's another way we can just skip our steps and just get our answer in a more efficient and faster way. But we'll go through both of them for this question as well. So first step is to make this equal to 0, as we know. So 2x minus 5 minus 5x plus 4 plus 5 is equal to 0. Important thing to note, our sign does not change in the denominator. It is the same thing. If the numerator, suppose, had plus 1 here, then we would get minus 1 here. Then it would change. But as for the denominator, it does not change. Okay. 2x. Now we say the restrictions. So our restrictions are whatever is in the numerator. So negative 5. Sorry, that was not what is in the new denominator. It's what adds up to 0. So we're just trying to eliminate that. Okay, x can't equal 5, negative 5, and x can't not equal negative 4 as well. Now we just do our common denominators. So again, we're just cross multiplying. We can skip 2 steps now. We can eliminate the denominators and just do the common denominators as well. So 2x minus 5, x plus 4. But if we want to, actually we'll just do our steps. We won't skip any steps for this one. X plus 5. This is over x plus 5, x plus 4. Again, these are brackets, you're not adding anything. And then this is x plus 4, x plus 5. Okay. All equal to 0. So then we're just doing our expanding, our rainbow method. So 2x times x is 2x squared. Just write for this. 2x squared. And then 2x times 4, they're both positive, so 8x. Because the x is attached to the 2. Minus 5 times x is minus 5x. Minus 5 times 4 is minus 20. We'll keep this all in the same line. So this is x plus 5, x plus 4. Next fraction, we have minus 5 times x, minus 5x. And minus 5 times positive 5, minus 25. So we're just making sure of our negatives and our positives that they match up. We also need to notice, we can take a note that you have an opportunity to expand here. But the question is raised that why would you need to do another step when you're just eliminating the denominator to begin with. So we don't need to touch this denominator at all. We just keep it as it is and just cancel it out. So we'll use this color. So x plus 5, we can cancel it out now. This gets canceled, this gets canceled. Now we can collect our like terms while we put them in the next line. So 2x squared is the only squared one. Plus 8 minus 5. Plus 8 minus 5, and then minus 5 again. So plus 8 minus 5x minus 5x minus 5 minus 5 minus sorry, I'm trying to say plus 8 take away minus 10 should give you negative 2x. Okay, then we have minus 20 minus 25, so that's just negative 20 minus 25, which is negative 45. Okay, now we have this trinomial, and again, when we have a trinomial, we can think of ways from past years on how to solve for x. So our most common would be to first see if we can common factor anything out. In this case, we don't. 45 is not divisible by 2. Then our next step would be to do decomposition. So that just means two numbers that add up to 90 and negative 90 and add up to negative 2. In this case, if you look at factors of 90, no numbers add up to negative 2. So when decomposition fails, what is the next step we do? Well, that would be to use a quadratic formula. Now, this quadratic formula takes time, but that's the case when we have nothing left to do. So we'll go through the quadratic formula quickly. So if you forget, it's just negative b plus minus b squared minus 4ac square rooted, and it's over 2a. So we'll go through this fairly quick. So negative 2 minus 2, so just 2, plus minus 2 squared, which is 4, minus 4, actually I'll just keep it 2 squared. We'll do this whole thing in one step. 4, I'm just going to sub it in, negative 45. You can check this in your calculators too. And then 2 times 2. And this whole bracket or square root thing over here should get you 364 divided by 4. Now, as usual, we'll have two solutions because there's a plus and there's a minus. So, in our plus side, we should get x is equal to 5.3. We don't have easy numbers to work with. We have some decimals. Next one should be negative 4.3. I just rounded to the next decimal place up. Okay, so these are our answers. Now, within the same steps, let's just use the shortcut method to see how many lines it does save for us. So, well, our question is, I'm going to rewrite the question for us. 2x minus 5, x plus 5. Okay, so I'll start from here. 2x plus 5. Oh, sorry, not plus 5. Minus 5. Okay. Minus 5 over x plus 5 is equal to 5, x plus 4. We can do, our restrictions are still there, it'll just be negative 5, negative 4. We'll keep that in mind. And then we'll do our 2 steps in 1. So we just have to cross multiply and just take care, just don't add, just eliminate the zeros, or sorry, eliminate the denominators in this step. So we should get 2x minus 5, x plus 4 is equal to 5, x plus 5. And it's the same step, so this we know is equal to 2x squared. And then plus 8x minus 5x minus 20. This is just 5x minus 45. Yeah. This is not, sorry, this is not 15, it's 5. Made a mistake there. It's not 45, it's just plus 25. Okay. And then from here on out, we can, since we have a square, we could just bring everything to this side to begin with. So 8x minus 5x. We'll just move over these as well so we can get these equal to 0. So again, we still make the equation equal to 0. We're just working a little bit quicker, if that makes sense. So 8x minus 5x minus 5x. And then minus 20 minus 25. Gives you 0. So we're left with 2x squared. Again, it's the same thing. It's negative 2x, negative 45, equal to 0. And let's take a look back here. Here we see how many lines we do save here. So we did this in like 3 lines, 4 lines actually, while that took the whole page to do. So how many additional steps do we have to do? But it's essentially the same thing. Okay, and that's it for that question. These are our answers. So for our last practice example, we're going to use a question that has an extraneous solution. Okay, so this says x is equal to x squared minus 10x plus 21 over 3x minus 12, and this is equal to x minus 5 and x over x minus 4. So we can see a lot of things that we can start to do, but let's see, the most common step is to common factor or simplify this question if there is. We say that this is a trinomial here, so we might want to decompose this if we want to, but I want to jump on that right away, just because sometimes it's easier to collect like terms rather than having x's in brackets right away when we're not done solving. And then we also have this denominator here that can be simplified further to make it easier on ourselves. So before doing anything, we could just simplify the question to make it easier for us. So it'll still be x squared minus 10x plus 21 over, you can divide this by 3. So it'll be just x minus 4. X minus 5, x minus 4. Now we see that our denominators are almost the same. We can state our restrictions now. That's the second step. So x cannot equal, on this side it's 4, on this side it's also 4. The 3 has nothing, it means nothing to us, okay? So there's that, and then we do our common denominator work here. So we could just cross multiply, we don't even need to cross multiply. At this point, we could just times this fraction over here by 3, because it's the same thing. This one just says 3 times x minus 4. So we could times this by 3, times that by 3, and we get x squared minus 10x plus 21, and this is equal to, we're just going to get rid of the denominators too, 3x minus 15. Again, we're just multiplying throughout. And we got rid of the denominators here, so if we want to write that down, 3x minus 4, and then 3x minus 4. Okay, now we have this. Now we could bring all this whole term over here so we can get to 0 because we do have an x squared. So we could work like this, so x squared minus 10x minus 3x, remember the opposite sign, plus 21 and plus 15. 0, you should get x squared minus 13x plus 35. And that is equal to 0. Sorry, not 20, 35, 36. That was an error. And now we see that this is a trinomial and it's equal to 0, so we can decompose now. It's also a simple trinomial, so what two numbers add up to positive 36? Sorry, multiply. What two numbers are multiplied to equal 36 and add up to negative 13? Well, in this case, it would be x is equal to, not equal to, my bad, x is minus 4, and x is minus 5. Our numbers would be 4 and 5. Not 4 and 5, 4 and 9. My bad. 4 and 9. Sorry, that's a really bad 9. Minus x is equal to 4, minus 4, and x is negative 9. Which is 0. And then our final answer is just x is equal to 4, x is equal to 9. Okay, before we feel like we've done all the correct steps, but we haven't looked at our last most important step, and that is to go back to our restrictions up, and we see that x cannot equal 4. So then we see that this solution over here cannot be our solution. So this x equals 4 is our extraneous solution, while our x equals 9 is our real solution here. Okay, and that's it for this question. And so moving on to our word problem. Our problem says a taxi is rented by a group of X people for $20 and the cost is shared equally. If there's one less person in the group, then each of the remaining people have to pay $1 more. What is X? So typically for any word problem, we're going to see what information is given to us. So the first thing I do is write my let statement. So we're going to let X represent the number of people, even though it says in the equation. Just reminding us. And then we need to see what is given to us. So the question tells us that the total cost is $20. And there's a group of X amount of people, and their cost is shared equally. If there was one less person than in the initial group, then they would have to pay $1 more, the remaining people left. So for this type of question, we could make a table to make it easier for us to understand what's going on. So we could have a total cost because we'll see that we could form two equations. The total cost for us will still stay the same, okay? There's a number of people present in both equations. Different number of peoples. And with the last column is the most important one. Since we are talking about cost, it should be cost per person. Yeah, okay. So our total cost is 20. In our first equation, if you can see what's happening here, our total cost is still 20 because that's the original price. And the original amount of people, so the initial group, is X. We don't know what the amount of people is. This is what it is. It's just X, okay? So our cost per person would be 20 over X. So to understand this, the total cost being 20 being divided by the number of people in the original group gives us how much one person pays, okay? For our second equation, number 2, we just have 20, and this time there's one person missing from our initial group. So it would just be X minus 1. So whatever he had in X minus one person. And the same thing for cost per person, then it would just be 20 divided by X minus 1. Okay, so now we just look at these two equations and see what we know. So we have 20 X minus 1, and then we have 20 over X. We see that the X minus 1 fraction is what people need to, it cost more money, while as this fraction cost less money. This is because the initial group has to pay $20 divided by the initial amount of people. But if there's one person missing, then it says you have to pay $1 more. So this is the one that costs more. So we know that these two equations have a subtraction. We're subtracting these two. We're finding the difference, okay, here. Since this is the bigger piece, this is the smaller piece of information given to us. And then this equation is all equal to 1 because it says that they have to pay $1 more. So we know that our equation has to be equal to positive 1, okay? So from here on out, we see that it's just a regular rational equation question. We just work our way through it. So we can move either way, however you want to do it. I'll just move it over equal to 0. So 20 x minus 1 minus 20 over x minus 1 over 1 is equal to 0. Then we just times, we state our restriction, obviously. A restriction, there's just one restriction. There's also 2 actually. X cannot equal 0 and x cannot equal positive 1. Okay? And then we do our common denominators. So timesing each by itself, and then this one, there gets 2 of them. Whatever you do to the bottom, do it to the top as well. So 20 times x minus 20, x minus 1, minus 1, x plus 1. So I'll put 0. And we can write this down for now, and we'll get rid of our denominators altogether. So then 20 times x is just 20x, minus 20 times x is minus 20x, and then minus 20 times minus 1. Take note of your negatives. It's plus 20. And then minus 1, you're just timesing it by itself. So it's just minus x minus 1. Sorry. And then x. Sorry, I'm writing this completely wrong. It's times by minus 1, so it's just x plus 1, x. So it's just negative x plus 1, x squared plus 1. Oopsies. Don't know why I said x squared. Okay. So now we should get, oh, sorry, this should be negative x squared minus x, my bad. Making this more confusing. Okay. So now we have 20x minus 20x and then minus x, so that should get you just 20 and these two cancel out, but there's a minus x, so just minus x. And then, I forgot my x squared. Our x squared is the most important. Minus x squared minus x. And then we have plus 20 right here. Okay. Now we have a simple trinomial. So we just need to see two numbers that times negative 20 and add up to negative 1. In this case, it would be x equal to 5, x minus 5, and then x plus 4. Oh, wait, this is the other way around. This, sorry. No, this is right, sorry. So it's x minus 5 and x plus 4. Sorry, it's important to see your own calculations. Even though I'm teaching this lesson, I see that I'm making mistakes along the way, and that's fine. You just need to watch out for them. So we do get x minus 5, and we get x minus 4. That's our answer. It's equal to 0. And then our solutions are simply x equals positive 5 and x equals negative 4. And then we just see do these equal our restrictions? 0 and positive 1? No, they do not. But also, since this is a word problem, we need to see what makes sense and is realistic. Can there be a negative amount of people present? No, right? So this just cancels out by itself. And then this is our real solution. So we can write our therefore statement. Therefore, x is equal to 5. There are 5 people. Okay. And that is it for our lesson today. Hope you learned quite a bit. If you ever need to solve, just follow these steps. And yeah.